Hey, welcome to Procedural Modeling tutorial in Houdini. First of all, if you haven't installed SideFX Labs, you can install it very easily by navigating to the shelf dock, Shelves, and click on SideFX Labs and install it from here. We will start by adding the Geo node. Let's call it Procedural Escalator. Next, I will create a project and prepare it for the next chapter. In Chapter 1, we will create one of the basic forms of escalator, and we'll start by adding a cube. To raise the cube to the grid level, there are at least two methods. In the first method, we will use these expressions. In the second method, simpler and faster, we will use the match size node. So, the first method, we add the transform node. And we introduce these expressions in translate x and translate y. To detect the axes, we will follow these indicators. In transform x, we enter $xmin and $imin. Cube is in the right place. The second method, match size. On the y-axis, we select minimum. And the same on the x-axis. We obtain the same result. Node transform. Delete. Next, we will change the size of the box on the x and y-axis. To size y, we add value 0.935. On the x-axis, we add 0.09. To avoid some changes to these values by mistake, we will lock these parameters. Create a group on primitives from the side. We add the group node. Select Keep by Normals. And reduce spread angle value to 20. Rename the group Delete. And make a copy. Select Union with Existing. And group the primitive from the opposite side, change the value to -1. We make another copy of the group node, and group the primitive on the x-axis. Here 0, and here -1. Select Union with Existing. Of course, there are other ways to get the same result. One of them is to use the blast node. Click here, and select the primitives will be deleted. After selecting, press Enter. Why this method is not good in procedural modeling? Let's see an example. Suppose that the number of primitives changes to the basic geometry. Add Divide node. Add more divisions. Let's see the result. The primitives are deleted. It is not what we need. But the groups are unchanged. Add the Delete node. Select the del group. Next, we will round the corners. Add the poly bevel. Increase the distance. And add more divisions. Here, we set 0.44. Next, we will group the front area. Add the group node. With a bounding box, we will indicate the area we want to group. Add bound node. Now we will increase the size of the box. Lower padding 0.3. And upper padding 0.3. But in the back, we make it smaller, -0.4. The points that are inside will be grouped. Connect a group and select Group Type, Points. Activate the option Keep in Bounding Regions and select Bounding Object. Rename the group to Bound. Add the Transform node. And select the bound group. Translate x to 0.5. And we mark the node. Add a null node and rename it in Rayleigh Start. At the end, we add a network box. In Chapter 2, we continue with the basic shape of the escalator. For the beginning, we will group these 4 points in 2 different groups. Let's start by creating a bound box. Add a group node. Group name, delete. Select keep by normals. Here 0. And here -1. Spread angle 50. Add the delete node, and delete the geometry that is not grouped. Select group delete. Operation, delete non-selected. Now, we will add the sort node. Select point sort along vector. In this way, the points will not change their position. Next, we add delete node. And delete all points, except point 2 and 3. Delete non-selected. Entity, points. On these points, we will copy 2 boxes. Add a box. Uniform scale 0.2. And here 5. Add node, copy to points. And now connect box and points. We have 2 intersecting boxes. To obtain a geometry without intersections, we will use Boolean. And we will set the intersect option. This box we will use as a bound object. Add group. At source data we connect the railing start geometry. Group name, in 1. Select points. And bounding type object. And connect geometry. Let's add group promote. Next we will promote the group in 1, from points to edges. Select edges and the group we want to promote. We need only this part to be in the group. We click here, an original group will be preserved. Next we will add mirror node. Let's make some changes. distance 0.1, and direction on x-axis, -1. Now, we will add another mirror node. And here we enter the same values. We don't need the original geometry. Uncheck Keep Original. At the distance parameter, we will create a dependency link between these two nodes. Copy parameter. Paste relative references. Now we will create the group out1. Select points. Group name, out1. And bounding type object. Next we will promote group to edges. Add the poly bridge node. Divisions 1. Spline shape select straight. In the source we select the group in 1. And in the destination select the group out 1. Now, we will continue with the bottom. We will basically repeat the same process for the bottom. Let's make a copy of the delete node and switch to delete selected. Also duplicate the copy and Boolean node. Next we will add the group node and connect the Boolean node to the second input. Select points and bounding type object. Group name in2. Next, we will promote in2 group to the edges, and then we will add mirror. And we also create a dependency link to the distance parameter. Now we will create the group out2. Select points and bounding type object. Make a copy of the group promote node and promote out2 group to the edges. Copy the poly bridge node and add the previously created groups. Next we will create a group delete that we will use later in the following chapters. Group name, del. Select keep by normals. Direction on the y-axis, -1. Spread angle 45. Let's narrow the propagation angle of the group. Next we will delete the groups we do not need. Add node group delete. And select the groups we will delete. Add group node. Select the geometry from railing start and connect it to the second input. We will create a bound and we will change its size. Lower padding 0.03 and upper padding 0.03. Select points and bounding type object. Rename the group in upper landing. Add the transform node. Next we will create a controller. Add a null and rename it in control. We will add two parameters, length and height. Parameters and channels. Edit parameter interface. Let's add a float parameter. Length. And select range, minimum 4. Block it. And the maximum, 15, is also blocked. And we add another parameter. That will be the height. range 0, 11, and block. Click Apply. Let's hide parameters we don't need. We will now create the dependency link between these parameters and translate X and Y. Select Upper Landing Group. But first of all, we will block parameters that we do not need. Length copy parameter. In Translate X, paste relative references. Copy parameter. In Translate Y, paste relative references. It can be seen that angle is too large in such a configuration. How will we proceed? We will take half the height value and add it to the length. So, let's get started. Height copy parameter. And plus. Paste relative references. And divide by 2. Let's add group combine. Group name bound. And here we also select bound. Let's stop here for a moment. We have this result, and the next task is to round these parts. So, we will need to group these primitives. Of course, we can create a special group for this task. The fact that the geometry changes its size and the number of primitive tasks seems complicated. But an effective solution is to try to use previously created groups. Or we go back to the simpler version of geometry and create the group there. In our case, the group we will use is bound, the group is on points, but this is not a problem, we will promote it to primitives. We return to group combine and select equals all but. In this way we selected everything outside this group. Add group promote. Promote the bound group to primitives. And rename it in bevel. And select primitives. Next we will add the polybevel node. Select the bevel group. Set the distance 0.293. And 3 divisions. Add fuse node. We will delete the groups which we no longer need. Add the clean node. We will delete everything except the del group. Add match size. We will align the geometry to the center. At the end, we add the null node and rename it in railing base. In Chapter 3, we will create the first detail of the escalator. And we'll start with delete node. Select the del group. Add poly extrude. Distance 0.057. Add polybevel. And set the distance 0.018. Next, we will exclude edges that have more than 90 degrees. Select Ignore Flat Edge. And select edges that are less than 80 degrees. Let's go back and add more divisions. Next, we will create UV. Add UV Flatten, and then add UV Quick Shade. We see that the texture was not evenly distributed on the surface. Next, we will create groups for UV seams. Add the Delete node, and select the Del group. Delete non-selected. Next, we will group the points only on one side. For this group, we will use a bound. Let's create a bound and size it up a bit. But on the Z-axis, we reduced the size. Rename the group in line. Delete points that are not in the line group. Delete non-selected points. Next, we will sort the points on the X-axis in ascending order. Add Sort node. Select a long vector. Here 0 and here 1. Let's put Add Node and connect points in a line. Select polygons by group. Without a sort node, the result will be something like this. Add node, resample. And set length 0.7. Next we will add in the group last and first points. Add the group expression node. Group name NPT. Select point valence. And click here. Select points. And we delete the points that are not in the group. Add copy to points. On these points we will copy a box. Add a box and resize it. Uniform scale 0.1. We will align this box to the handrail. So, add node match size. In the second input, we connect handrail geometry. On the axis X and Y, none. And Z, center. We will change cube size on the Y-axis to include entire geometry. Add group node and connect the boxes to the second input. Group name UV Scene 1. Next, we will promote the UV Scene group to the edges. Add group promote node. Select edges and UV Scene group. And we will keep only the original group. We see that the same result is also at the top. Let's open UV viewport to see more clearly what is happening with our UV. Select UV Scene Group. It is a little better, but we will continue. We will create 2 more groups, one somewhere around here and here. The most efficient solution is to use what we have already created. So, we will use the UV Scene group. Add Group Expand. Group name, UV Scene 2. Base group, select UV Scene 1. And 10 steps. Now we see that the selection has increased by 10 steps. Add another group expand. Group name, UV Scene 3. Base group, select UV Scene 1. Now we will promote created groups to edges. Add UV Scene 1, 2 and 3. And we exclude unshared edges. But in our case it does not change anything, just optimization. Now we are testing to see if there are any errors. Everything is fine. We continue to add previously created groups to the scene parameter. It's much better now. Add UV Transform node to see how the animation works on handrail. Change scale. Now we will animate UV on the x-axis. Add Soften Normals node. Soften Angle, 90. Next we will add the Clean node. Now we will delete all the attributes and groups that I no longer need, except normals and UV. At the end add a null, and rename it in handrail. In Chapter 4 we continue with another element of the escalator. We will create the balustrade, which is composed of several as elements decorative holes and a control panel. And we start with polyfill to cover the sides of the geometry. And we see that with the basic settings, the geometry has defects. The solution is to change fill mode to single polygon. Add the transform node. And we will change the scale on the Z-axis. Block parameters on the X and Y axis and set, on the Z-axis scale, 4.1. Add the fuse node to delete any intersected points. Add a null, and rename it in balustrade base. And we'll make a copy. Add the group node and group the primitives that belong to the Y-axis. Spread angle 45. Add delete node. Select group 14 and delete all primitives that are not in this group. Next group is on points, and we will create it with the help of a bound box. Now we create bound box for the group. We will group the points only from one side. Lower and upper padding 0.01. And reduce the size to include only half of the geometry. And connect it to the second input. Next, we will delete the points that did not enter the group. Add the sort node and sort the ascending points on the x-axis. Select a long vector 1 and 0. And with the add node, we connect the points in a line. Add the resample node and change the number of points. Length 0.9. Add the group expression and group the first and last point. Group name NPT. Add split node and divide the group NPT. Add a null and rename it in endpoints. Next, on these points we will copy two boxes. We add the copy to points node and a box. Uniform scale 0.1. and size 4. Add the group node. Group type, points. And group name, control. Connect the box to the second input. And we will align the box to the center of the geometry. Add match size. In the first input, we connect endpoints, and in the second, the geometry from the delete node. On the X and Y axis we select none. Add the node group expand. Base group select, control. And steps 2. Add the group promote node, and promote expand group to primitives. New name, control panel. And delete all primitives that are not in the control panel group. Add transform node. We decrease the scale a bit on the Z-axis, 0.32, and translate Z, -0.04. Now we will extrude these primitives. Add the poly extrude node and set the distance 0.051. Select output back. And we make another extrude on the opposite side. Distance 0.002. Return to the first poly extrude node and activate Back Group. And here, we select the Extrude Back group. Add a null and rename it in panel. We return to the split and continue with the remaining points. Add copy to points and copy a tube on these points. Select primitive type, polygon. Add end caps. Radius scale 0.054. And height 0.3. We will create the holes through Boolean. Add the tubes in the second input. In the first input, we connect the base balustrade geometry. Add the match size node. And align the tubes to get the holes in the center. On the X and Y axis we select none. And connect to Boolean. Next we will align the control panel with the tubes. Copy the parameter from the transform node. We also add a transform to the tubes. And paste relative reference on the Z-axis. Add poly bevel. maximum normal angle, 46. Distance, 0.012. And also through Boolean, we will add here control panel. Add Boolean. Copy polybevel and connect it to Boolean. Reduce the distance to 0.005. Add a null, and rename it in balustrade. Next, we will add details to the control panel. Add delete. And we create another group in the polyextrude node. Front group. Select the extrude front group, and delete non-selected. Reverse the normals. Add polyextrude. Inset 0.008. And let's divide geometry into two separate streams. Add split. Group, extrude front. Next add node, circle from edges. And set radius, 0.041. Add polyextrude. Distance, 0.03. Add another polyextrude. Inset 0.017. Return to the first poly extrude node and activate the front group parameter. Select Group, Extrude Front. Create the second group, Extrude Front 2. Add another poly extrude. And select Group, Extrude Front 2. Distance 0.021. Add poly bevel. Distance 0.006. Divisions 3. Return to the first poly extrude and activate side group. And here activate front group. Rename it in Extrude Front 3. Return to poly bevel and select Group, Extrude Front 3. Maximum normal angle 80. And add Extrude Side Group. Add Soften Normals. Soft Angle 38. And again we return to the split node. Add poly extrude. Distance 0.006. Add merge node and copy Soften Normals. Add Subdivide node. Add Group Expression. Group Type Points. Select Point Valence. Valence 2. We promote this group to primitives. Add Group Promote. Select Group 1. And select Primitives. And delete the geometry that is not in Group 1. Add Resample. Maximum segments, 12. Next add node, circle from edges. And set radius, 0.009. Add poly extrude. Distance, 0.005. And add it in merge. Next we will create UV. Add UV flatten. Let's make a copy to the UV quickshade node. And start creating UV scene groups. Add group node. Group name, UV Scene 1. Select Keep by Normals. Spread angle, 52. Copy the node. And select Union with Existing. Direction, -1. Add another group, rename it in UV Scene 2. Spread angle, 52 and on the y-axis -1. Add group promote. Select edges and groups UV seam 1 and 2. Return to UV flatten and add created groups to seams. Add UV layout. Now UV does not intersect. And for the control panel we will also create UV seam groups. First group we will create here. Change to UV seam 3. Rename extrude side to UV seam 4. And here, we rename in UV seam 5. We have changed the names of these groups, so we will have to add them again. Next we will promote these groups to the edges. Add group promote. Select groups UV seam 3, 4 and 5. Activate parameter, include only elements on the boundary. Select edges. Here we will change the group UV seam 3 in front. And we create another group for this element. Add the remaining groups in UV flatten. Add network box. Copy node clean. We see that handrail is in the center. We will move it to the edge. Add merge node. After the poly extrude node, we will add the transfer node and move the geometry on the Z-axis to the edge. This chapter ends here. In this chapter, we will create a panel on the outside of the balustrade. Add the group node, and we group the geometry from the outside. Group name, exterior. Select Keep by Normals. Direction, -1. And spread angle, 55. Add delete node. Select Group, Exterior. And delete geometry that is not in this group. Add poly extrude node. Distance, 0.026. And inset, 0.065. Add reverse, and next we will delete the geometry from the edges. Add delete. Select group exterior, and delete non-selected. Add another poly extrude. And set distance 0.026. Disable output front. And add output back geometry. Add poly bevel. Maximum normal angle 56. Distance 0.01. Next we will add group delete. And delete the groups we won't need anymore. Add match size. Next we will copy a box on a line, and with it we will divide this panel into equal compartments. Take the line from the second output from the split node, and connect it to the match size. Add a box. Size 0.1. But on the y-axis we set 100. Uniform scale 0.3. And manually, we will reduce the size of this face. And copy the box on points. Add Boolean and make the holes in the panel. Return to match size and set on the Z-axis minimum. Add another poly bevel. Maximum normal angle, 40. Distance 0.082. Add soften normals node. And set soften angle, 35. Add null and rename in exterior panel. Next we will create UVs. Add UV flatten. Return to the Boolean node and activate B inside A. Let's see where this group is located. We will use this group as UV seam. Rename in UV seam 1. And next we will promote it to edges. Add group promote. Select UV seam 1. Edges. And add it in UV flatten. And at the end, we copy the quick shade and clean. In Chapter 6 we will create deck base. Let's start. We add the group node. And we will group the bottom of this geometry. Group name, deck base. Select Keep by Normals. On the y-axis add -1. Spread angle 55. And delete everything that is not in this group. Add delete. Group deck base. Delete non-selected. Add the group node, and we will use the same method that we used before. We will use a bound box to group only one edge. Add bound box. Lower and upper padding 0.1. And on the z-axis reduce its size to -0.2. Rename the group in del points. And delete points that are not part of the group. And as usual, we add sort, and then with add node, we will create the lines. Add poly extrude. Distance 0.3. And another poly extrude. Distance 0.39. And further we will enlarge the bottom of this geometry. As a result, we will have a base wider than the top. Next, add group node. Select Keep by Normal. Spread angle 75. Direction on y-axis -1. Group name, deck bottom. Add the transform node. Select group, deck bottom. Scale on Z-axis, 1.165. Translate on Z-axis, -0.065. Add poly bevel. Distance, 0.02. Maximum normal angle, 72. We will create a hole with handrail geometry. Add Boolean. And in the first input we connect handrail geometry. We return to handrail, and from poly bevel we will take geometry for Boolean. And select subtract B from A. Next we will create another hole in the front. Return to the deck base group. And add the peak node. This node moves primitives, points, edges or breakpoints along their normals. Select group, deck base. Distance, -0.045. Now I need to separate only the primitive from the front. A good method is to separate the points at the corners from the rest of the points. Add group expression. Group type, points. Select point valence. And valence, 4, and we delete the grouped points. Let's move the geometry forward a bit. Add peak node. Distance, 0.03. Add transform. And we will reduce the size of the Z-axis. And we raise it a little higher. Add poly extrude. Distance 0.08. We need the extrusion direction to be on the opposite side. So we add reverse. Select Output Back. And with Boolean we make another hole. Add poly bevel. Maximum normal angle 80. Which means that only sharp edges will be selected. Distance 0.01. And divisions 4. Add null and rename it in deck base. Now it's time to create UVs. We return to the first poly bevel node and activate Edge Fillet Polygons group and change its name to UV Seam 1. In Boolean, we activate group A inside B, and it will be UV Seam 2. And the second Boolean select the same group. Promote groups to the edges. Let's see what the seams groups look like. On the edges we see that there are 2 lines. Of course only one would be better. Now I will show another example where there is only 1 line, and I will use the groups created above. I make a copy of the node group promote and I will delete all selected groups. I go back to the poly extrude node and select side group. And I will select the group created above. And we have only 1 line selected. And with the deck base group I will select another line here. Let's go back to the previously created groups. Add UV layout. We copy the nodes, UV quick shade, clean and soften normals, and add them to the deck base. Further we will reduce it from the length of the geometry. Return to the Add node. Add group expression. And select point valence. We add the delete note and let's see what we got. At length we can also influence from here by increasing or decreasing the spread angle. And at the end we will add a network box. In Chapter 7 we will create the escalator steps. And we will use as a baseline created for balustrade. From the Add node, we add a null and rename it in steps. Next, we will increase the number of points. Add resample. Length 0.251. And we shorten the line on both sides. Add group expression. Select point valence. Valence 1. Group type points. Add delete. Select group 1. And we will increase the density of points. Add resample. Length 0.012. This density will give us a continuous and slower movement. Add group expression. And we group once again the first and last point, but this time we will lower them down on the y-axis. Add transform. And select Group 1. Transform on the y-axis, minus 0.37. Add another transform node and lower line to the grid. Add sort node and sort the points in ascending order on the x-axis. We will continue to animate the points. And we add another sort. Point sort, shift. And offset, -$FF. This is the ascending animation. Make a duplicate to the sort node. And delete minus. Now we will add a switch. With it we will choose the direction, down or up. Next we will select points on which we will copy the geometry of the steps. Add group by range. Group type, points. Range, 20. Group name, stairs. And delete the points that are not in the stairs group. And we connect the point between which the distance is too small. Add fuse. Snap distance, 0.121. Add a null and rename it to steps. And we start creating geometry for the escalator steps. Add box. We will resize it. On the axis X, 0.3. On the axis Y, 0.2. And on the axis Z, 0.1. Add poly bevel. Click here. Select edge and press enter. Distance 0.259. And divisions 6. Add match size. For the x-axis select minimum. Next we will create a group on one of the parts and we will change its size. Add group. Group name, scale. Spread angle, 50. Add transform. And we lock all parameters except translate Z. (1.7) And delete sides. This is only for optimization. Add copy to points. Next we will continue to create UVs. Delete these groups, here we will have fewer. First UV seam group we will create in polybevel. Select Edge Fillet Polygons. Rename in UV seam 1. And the second group. Add group. Group name UV seam 2. And select Keep by Normal. Next we will promote these groups to edges. Select groups UV seam 1 and 2. And at the end we will see how it works, and we will add a network box. In Chapter 8 we will create the part that covers the back of the escalator. We will use the line we created in the previous chapter. Select Node Delete. And add a null. Rename it in truss. Next, we will reduce the number of points. Add resample. Length 0.68. And sort the points in ascending order on the x-axis. Add sort. Point sort along vector. Add transform. Translate y -1.1 and translate z 0.08. Next we will create the basic geometry. Add poly extrude. Distance -0.62. And add another poly extrude. Distance 0.14. Select Output Back. Next we will delete the primitives that are at the top. Add group. Select Keep by Normals. Group name Up. Spread angle 45. Add delete. And select group Up. Add polybevel. Distance 0.029. Maximum normal angle 87. Now we will group the side of the geometry, after which we will change its size. Add group. Group name Scale. Select Keep by Normals. Spread angle 85. And add transform. Select Group Scale. We will lock all parameters except translate Z. Set the size 1.7. Now we will select the geometry from the corners. There are many methods to do this. The most effective in this case is to select edge fillet polygons in the polybevel node. But let's see another method. Add measure. This node measures the area of each primitive. The smaller primitives are marked in blue and the larger in red. Let's move on to geometry spreadsheet. And we will change the range of the area attribute. Will be from 0 to 1. Which means that the largest primitive will have the value 1 and the smallest very close to 0. Add group expression. Next we will group the primitives that have the area attribute greater than 0.2. In vex expression we add the following expression, attribute area greater than 0.2. Add delete. Select group 1. And delete non-selected. Add poly extrude. Inset 0.006. Exclude output side. Add another poly extrude. Distance 0.011. Inset 0.03. Add subdivide. Change subdivide algorithm. Next we will deform the geometry. Add point jitter. Scale 0.007. Add merge node. Add attribute delete. Delete the area attribute. And align the geometry to the stairs. As bound geometry we will use steps. Add match size. In the first input we connect the truss geometry, and in the second input steps geometry. On the X and Y axis set none. Add a null and rename it to truss. Add soften normal. Soft angle, 43. Delete groups and attributes that we no longer need. Add clean. And delete all attributes except normal and UVs. And in the end, we will create UV scene groups. Return to Poly Bevel. Select Edge Fillet Polygons and rename in UV Scene 1. And delete UV Scene 2. And finally we check how it looks escalator and add a network box. In this chapter we will create one of the simplest components of this escalator. And as a basis we will use the line created in the previous chapter. Select the transform and add the null node. Rename it in Low Deck Interior. Add the Poly Extrude node. Distance 0.051. Next we will lower the edges a bit. Add group expression. And select the points at the edges. Group type, points. Valence, 2. And with soft transform, we lower them. Select group 1. Soft radius, 1. translate y, minus 0.05. Add poly extrude. Distance 0.041. Inset 0.029. And activate group front. Add transform. Select group, extrude front. Translate y, minus 0.022. Next we will create UVs. Add UV flatten node. Copy UV quick shade. And rename the group previously created in UV Scene 1. And select group UV Scene 1. As usual after UVs, add the nodes clean and soften normal. Connect it to the merge node, and then we will adjust its position. Add transform. We bring it closer to the edge and raise it above the stairs. I think I will disable soft transform. And I'll raise it a little higher. As usual at the end, we add network box. And the last element we do in this part is landing floor. And again we will not create from scratch, but we will use truss geometry. Select Poly Extrude and add a null, rename in Landing Floor Plate. Add the group node. Rename the group to Sides and set the parameter Keep by Normals. Spread angle 50. And change direction. Copy the group node and change the value to -1. And select Union with Existing. Next, delete primitives that are not grouped. Add peak node and move the geometry forward. Distance -0.025. And add Poly Extrude node. Distance 1.2. We see that our geometry is not perpendicular. And the problem comes from here at these points. We will solve this in a few simple steps. Add bound. And Boolean. Connect geometry and bound. Lower and upper padding 0.01. And with Boolean we extract the geometry that stands perpendicular. Select Intersect. We create once again a group on the axis X. Add group node. Enter the same values in Keep by Normals. and group name landing floor. Copy and select Union with existing. And set the value to -1. Add delete and delete everything that is not in the landing floor group. Add match size. Next, align the geometry on the center. Add the peak node. With it we will control the depth of the geometry. Distance -0.66. Add poly extrude. Distance 1. And we mark it in red, because with peak node we will change the landing floor position. And we add another peak. In this way we control the back and the front. Group landing floor. Distance 1.5. If we set the length with peak, the width will be set automatically depending on the width of the steps. Add match size. And in the second input we add the geometry from steps. On axis, X and Y, none. Select Scale to fit. And we leave only Z scale. Next, add poly bevel. Distance 0.013. Add Boolean. Add the geometry from deck base. Before the match size, we add a bound and enlarge it on the Z-axis. And with the opposite side we solve through the mirror node. Add mirror node. Without keeping the original geometry. Select axis Z. And we will transfer the geometry to the opposite side. And combine the geometry with the merge node. And we will delete the bottom geometry that is not visible. Add delete. Select normal. Spread angle 19. On axis Y, -1. Add a group. Group name, up, and select, keep by normals. Next add poly extrude. Group, up. Inset, 0.018. Make a copy. Inset, 0.023. Distance, -0.01. Return to group node and change spread angle to 10. Next we will create UV. We will use a single UV seam. Select poly bevel. And then edge fillet polygons. Connect to see what else needs to be corrected. It needs to be raised above. Add a transform node and raise it to the desired level. And at the end, we add a network box.